Hi everyone. In the first part of the lecture 7, rectifiers are studied. This figure shows a rectifier. We have already analyzed it. With the constant voltage model, let's analyze it again. When the input voltage is smaller than VD on, the diode cannot be turned on. Therefore, the output voltage V out should be 0. When the input voltage is larger than VD on, only VD on can be applied to the diode. The remaining excessive voltage should be applied to R1. We can expect the following input-output characteristics. Let's see the simulation result. The right figure shows the input-output characteristics. In this case, what is VD on? It is around 0.6 volt or 0.7 volt. Up to this voltage, V out is quite small. Of course, it is not exactly 0. Beyond VD on, it looks like a line whose slope is 1. In other words, it copies the input with a small offset when the input exceeds VD on. On the other hand, when the input is smaller than that, it is not copied. When a time-varying input voltage is applied to a rectifier, the output waveform is modified by the rectifier. In this example, a purely sinusoidal voltage is applied to a rectifier. Both the input voltage, a red line, and the output voltage, a blue line, are shown as functions of time. As you can see, the output waveform is significantly different from the input signal. Consider a sinusoidal input signal and a rectified output signal. Here, U is the unit step function which gives unity only when the argument is positive. When you calculate the frequency component, the input signal has only a component at the frequency f. However, the rectified signal has a DC component, a component at f, and components at multiples of f. For example, it can have a 2f component, a 3f component, and so on. Schematically, when a rectifier gets an input at a frequency f, it generates outputs at many frequencies. Coming back to the rectifier, in this case, a capacitor is introduced. Let's guess the output waveform when a sinusoidal input voltage is applied. Initially, the voltage is assumed to be 0. Therefore, the capacitor voltage is also 0. When the input voltage exceeds a VD on, the diode is turned on. The diode conducts a current. The charge is stored in the capacitor. The output voltage increases. On the other hand, when the input voltage is lower than VD on, the output voltage does not change because the diode does not allow it. At every period, the output voltage increases. Eventually, a DC output voltage will be established. This figure shows the numerical result for capacitance of 1 microfarad. As discussed in the previous slide, the voltage rapidly increases in the first period. In the next period, it still increases, but very slowly. After several periods, we have almost a DC voltage. Therefore, the circuit successfully generates a DC voltage from a sinusoidal input voltage. In the second half of the lecture 7, the small signal analysis is introduced. Thank you.